Hi, I am Serena and I'm gonna give a demo for my production project. The topic for my project was Latency Aware Microservice Application Deployment in Kubernetes Cluster. In my project, in my product, microservice demo application have been deployed in the cluster, and then we are able to monitor its performance from different visualization tools. In reference to it, it started with the deployment of Kubernetes cluster, following with deployment of microservice application. Then we had to move forward with deploying different services to monitor the task. I have successfully deployed 4 different visualization tools. The product I've deployed is an open source application, and let me show the link. This is gonna be the link for it. I've just searched it on Google. I manage the infrastructure to enable the open running application in Kubernetes cluster. Moving forward with the coding, the command kubectl get nodes. All the 4 nodes are ready. It means we have successfully configured all the VMs as a cluster, but this is not the cluster we are eventually used to deploy the application. So I've used the VM2. Where is the terminal? So this is going to be the terminal. Let me just hide it. Moving forward with kubectl get pods. There you go. These are the pods that are running on it. We have few pods running. It shows, yeah, we've got all the pods running. Due to the challenge I have with CUI, with CNI, that is the reason I am facing content container creating over here. If I'll do the same thing, yeah. So because of this issues, I chose not to work on this one and move towards here. Let us go with kubectl get svc. So these are all the services that are used in the cluster. Now let's open the application that we have deployed. It's in the services and the name should be front-end external. Let me copy it and open the next tab. Or it would be easier. kubectl forward svc slash paste it. We need to check the port for the front-end host type 8444. And here is it's number 80. Just input it, like just forwarding it. And now let me see, I guess this is the one, and this is the application that we have deployed. Yeah, it's a product application. It's like I've got it from the Microservice demo code from Google. You can even get the source code from here. Moving on with next, simply type content over here. Just gonna start on the back. So this gives a very nice overview of the workloads which I've got, like cron jobs, demonstrates, deployment, jobs, pods, replica sets, reputation controls, everything. Like, and then we have got cluster review. It even gives the cluster overview of RBAC rules as well. Nodes and forward, you can filter in the top over here to search any of it. And on the side, it has got the cluster selector, and we can even switch it easily. So you can go on in any one of the two workloads and see all the and see all the meta status and like the pods conditionally, pretty much everything related to pods in it. Like, let us just click any one of the pods. Just click this one. Yeah, pretty much we have got everything like status, container service, condition, everything is over here. We've got meta. Yeah, let's take a look on resource viewer. We can get a figure of all the resource and all the dependencies over here. So yeah, this is gonna be the pod, main pod. We have got two service, one service count, and replicant is tied into deployment over there. So yeah, this is like worthy using to see all the dependencies of component to troubleshoot them. Next, I'm gonna go for the locust, which is load generator. Here it is. Let me just copy it. Copy, remember the number, that is 80. Roll forward and SVC. Just paste it. Load generator. What was its number? 8890 80. So the load generator was, yeah, this is gonna be the locust. I've done it in locust. On this statistic page, we can see on the top right corner there is a stop and reset stats, number of users that can be edited, and we have the host as well. On the statistic page, we can see the number of requests that have been made, how many was it failed, the average response with random values of like 0 to 2, 0 and 2. The average should be around 2 sec or 1 sec. We also have got charts in here. Yeah. So these charts are going to show us the request per second, the failure per second, and yeah, the response time and the number of users as well. And here's the exception part. Exception is when you have something is excluded. In this case, there are no exceptions over here. And the locus is something like Grafana, but this one is picking up all the load testing of the number of users in the locus. Towards the Grafana, we have got name Grafana over here. Just need to copy. And in this browser, similarly, kubectl port, then forward, paste the name, and it was Grafana 9080. It was 80, and just let us refresh the page for Grafana. So yeah, this is the dashboard for the Grafana. Grafana is like multi-platform open source analytics and interactive visualization web application. It can produce like charts, graphs, and alerts for the web when connected to supported data source. Like if I want to see the dashboard for the namespace pods, we can see like the current read bytes received and transmitted. They are like bandwidth, transmit bandwidth. We can examine all this thing from here. I have used Prometheus. I've installed it, but like I was not able to go deeply about it. But still, I'm gonna show it. Copy, find the dashboard, kubectl. SVC dash, pasting it, and the number 4. Sorry, it is not Grafana, it should be Prometheus. Yeah. And the number would be 9090. What's gonna be its port? We've got Prometheus 9090. This is going to be the dashboard for the Prometheus. Yeah, I was watching about the info. This is the graph. That's everything in the Prometheus. So this is the YAML file that I have deployed in the cluster. This is provided online, and in this YAML file we can see like a Kubernetes deployment requires the API version, kind, meta, specs, replicas, selector, templates, pods, container names, images, and ports to function properly. So the API version specify API version, which is FV1 over here. The kind represents the Kubernetes resource. The metadata includes the deployment's name and labels. The specs specifies the state of deployment, number of pods, of replicas, selector, and template. These facts assist in efficiently managing the deployment in the cluster. So in the conclusion, deploying a microservice application in Kubernetes clusters offers significant benefit in terms of scalability, resource utilization, and reliability. Using the dashboards like Prometheus, Grafana, Locust, Octant, it enhanced the development process by providing package management and monitoring functionalities. Thank you. That's everything for my demo.